8 and 12. Welcome to another series of iCamp lessons. So today we'll be covering Euclidean Geometry. So this is part and parcel of June exam preparations. It applies to both grade 11 and grade 12s. But this video was done specifically for grade 11s, but I believe that also grade 12 could benefit from the same things. So now let's look at what we have here. So we are looking at question 8, which is from a previous question paper. So we are being told here that in the diagram, MP is a diameter, right? So MP, this is MP, is a diameter of a circle centered at O. So this means that the center, that's the center. And then we are being told that MP, which is the diameter, cuts chord NR, which is this chord, at T. As we can see, it cuts it at T. And then we are being told that radius NO, this is a radius NO, and chord PR, MN, and MR, this is MR, are drawn. And then we are being told that R1, we are being told that R1 is equals to 69. So that's R1, right? So now we are being told that determine giving the reasons, right? So most of the time when we do Euclidean geometry, you will have to give reasons, right? So we are being told that determine giving reasons the size of R2, right? So where do we find R2? This is R2, right? So it's this entire angle, right? So we are being told that we need to find the size of R2, right? So let's write this, which is gonna be 8.1.1. So we want the size of R2. So in order to find the size of R2, right, I am going to look at triangle MPR. This is going to be triangle. This is the triangle that I'm going to look at, right? This is the triangle that I'm going to look at, right? So I am looking at in triangle MPR, right? In triangle MPR, right, I was told that MP is a diameter, right? So if MP is a diameter, that makes this side of the circle a semicircle, right? So this becomes a semicircle, and this also becomes a semicircle. And what do we know about angles on a semicircle, right? Angles on a semicircle, this entire angle will give us what? 90 degrees, right? Angle R, it's going to give us 90 degrees. Why? Because it's angles on a semicircle. So angle R, the entire of angle R, is going to be 90 degrees, and our ring is in, it's going to be angles on semicircle, right? And then now if we have an R, right, so this is R, so this entire angle is R, right? Its entire angle is R. But remember, so what makes up R? So R is made up by angle R1 plus angle R2, right? We don't have to provide the reason. This is just an arithmetic series sequence, right? So now if we know that angle R is 90 degrees, we are just going to substitute 90 is equals to what is R1? R1 is 69. This is R1. R1 is 69. So we substitute R1 plus R2. remember we want angle R2. So this is going to be R2 is equals to 90 minus 69, right? And then if you punch your calculators, your 90 minus 69, it's gonna give you 21 degrees, right? So you always have to write 21 degrees, right? Another approach could have been that if you look at the same triangle, remember what we know about angles at the center. We know that this is going to be 180, right? This is going to be 180, and if that is 180, what do we know about angles at the center? So the angle of the center is twice the angle at the circumference, right? So if this is 180, this was going to be 90 degrees, and then from there we apply the same rule, right? So that's how we solve 8.1.1. So now let's look at 8.1.2, right? Let's look at 8.1.2. So what I'm going to do now, I'm going to erase here, right? I'm going to erase here. So I'm looking for what? I'm looking for angle O1. This is angle O1, right? This is angle O1. So my approach to solving this, right, is I am going to look at triangle M and MR. This is the entire triangle that I'm going to look at, right? So that's the triangle that I'm going to be looking at. So now what do I see? So I see this angle, right? And this angle will have a relationship. And what will be that relationship? It will be that angles at the center is twice the angle at the circumference, right? So now already I know that angle O1 is going to be twice angle R1, right? So now my reason is going to be angles at center is twice the angle at the circumference, right? As long as you find a way of writing this, I think the easiest way of writing this is actually saying is twice the angle at the circumference, right? So you get it. And then from here we are just going to say O1 is equals to twice, what is R1? R1 is 69 degrees, right? And then from here we just say 2 times 69, that's going to give us 138, right? So that's how we can find angle. That's how we can find angle O1, right? So you just look at triangle MNR. Great. Now let's look at 8.1.3. 8.1.3, right? So if we are looking at 8.1.3, what we are looking for here is M1. So let's just erase this and see M1. So we are looking for this angle. right? So we are looking for this angle. So the best way in which we are going to look at this is I am going to look at this triangle, right? This entire triangle like this. These two triangles. That's what I'm going to look at, right? I'm going to look at both those triangles, right? So what I can simply notice, right, is now I have a same segment. So I have a segment. So this is going to be my segment, right? Okay, let's use this. So this is going to be my segment, your NR, right? So what do we know about angles in the same segment, right? So angles in the same segment, or angles subtended by the same segment, are equal. So that means that M1 is definitely going to be equals to R2. Excuse me. So we already know that R2 is equals to 21 degrees, right? So therefore we are going to say M1, angle M1 is going to be equals to angle R2 equals to 21 degrees, and then our reason is going to be angles in the same segment, right? That's quite simple. I always tell my learners that if you grasp the concepts first in the introduction of geometry, the theories and what they mean, everything else becomes just application. It becomes easy, right? So that means that your angle M1 is equals to 21 degrees. Right, so we've already given a reason for that. Great. So now let's look at the last question, which is 8.1.4. Right, so I think we're gonna need space. So this is what we can do. Because we need space, so we're just gonna copy this, come here and paste it, and then we can continue, right? Okay, let's move it a bit up. Perfect. Great. So now we are looking at 8.1.4. So we are being told that we want M2, right? So where do we find M2? This is M2, right? This is M2, right? So what we can do, we can just insert the values that we already had. So we knew that R2 is 21. So we know that R2 is 21 degrees, right? And we know that O1 is 138 degrees, 138 degrees. So that's O1, and this is that. And we also know that M1 is 21 degrees, right? So this is 21 degrees. Great, perfect. So now we are being asked to find M2. If it is further given that NO, so this is NO, right? NO is parallel to PR, right? So it means that this line is parallel to this one. Great. Now, before we even delve into answering that question, right? I'm gonna take you to grade 9. I think it's grade 9 or 10 mathematics. So if two lines are parallel, what do we know about their alternate angles? their alternate angles is going to be equal, right? So that means that that angle, this angle, right, which is angle R2, is going to be equals to angle M2, N2, right? And then the same is true for angle O2, right? Angle O2, right, which is this angle, is going to be equals to that angle, right? Why? Because it's alternate angles. It's alternate angles. This is how you identify alternate angles. And the other one, even here. Great. So remember what we want. We want M2, right? We want M2. So that's our first step. The statement that they gave us has already given us a clue, right? It has already given us a clue. So what I'm going to do, right, is I know that if I find this angle, which is angle O2, if I find angle O2, that means that I would have angle P. And if I have angle P, remember I also have angle R, right? That means that in this triangle, the only angle that I'll be left with is this one. And I can do the sum of angles in a triangle, right? I'm going to repeat that. If I can find this angle, right, it means that I already have this one because I've found this one. Why? Because of what we've already said about alternate angles, right? Remember that we know that this entire angle is going to be 90 degrees, and then we are going to find the value of this angle. That means that we can find this, right, by performing the angles in a triangle. Right? So that's what I'm going to do. That's what I'm going to do. Great. So let's see that now. Right. How can I find angle O2? Right. If I look at this, right, this forms a straight line, right? Why? Because I already know that this is a diameter. So it means that the sum of O1 plus O2 is going to give me what? 180. Why? Because it's angles on a straight line, right? So I'm going to say angle O1 plus angle O2 is equals to 180 degrees. Why? It's angles on a straight line, right? So what is O1? O1, I already know it. It's 138 degrees. I don't know O2 is equals to 108. So now I'm going to transpose. So it's going to be O2 is equals to 180 minus 138, right? Degrees. So that means that my angle O2 is going to be what? It's going to be 42. If you punch your calculator, you should be able to get 42. Right. So now I have angle O2, right? Remember what we said. We said angle O2 is going to be equals to angle P, right? Why? Because we have alternate angles, and this is always important. On O is parallel to PR, right? Because for alternate angles to be equal, we need parallel lines to exist, right? So perfect. So that means that O2 is equals to angle P, which is equals to 42 degrees. Great. So now we have angle P, we have angle R. So angle R, the entire of angle R is 90. So it means that we can find what? We can find M2, right? So this is the triangle that we are going to focus on. This is the triangle that we are going to focus on, right? So in triangle, so it's going to be triangle MPR, right? In triangle MPR, so we have M plus P, right? So in this case, we are not just going to say M, it should be N2, right? If you remember well, this is M2, right? So we have M2, we have P, and then we have R, right, which is going to be equals to 180, and the reason is sum of angles in a triangle, right? So M2 is what we are looking for. We are looking for M2 plus, what is P? P, we already know that P is 42 degrees. What is R? R is 90 degrees. Remember, we did even say here that R is 90 degrees because it's angles on a semicircle. So we have R plus 90, right, which is equals to 180 degrees. Right, so now we are going to have M2 is equals to 180 minus 42 minus 90. So M2 is going to be equals to, if you punch this on your calculator, what answer are we getting? We should be getting 46, oh no, it should be 48 degrees. Right, perfect. So now we already have M2, right? We already have M2. Perfect. So this is how we find M2. Now let's look at the following question. Great. So now let's look at question 8.2, right? So now we are being told that in the diagram below, ABCD is a cyclic quadrilateral, right? Is a cyclic quadrilateral. So we have ABCD, right? It's a cyclic quadrilateral, and we can see that it is indeed a cyclic quadrilateral. A touches a point in a circle, point in a circle, a point in a circle. So AB and DC, so this is AB and DC are produced to meet at E, right? So AB and this, AB and CD are produced to meet at E. And then we are being told that AD, right? So AD and BC are produced to meet at F, right? Great. And then we are being told that angle AFB, so AFB is equals to 2x, and then DAB, right, all right, this is DAB is 3x, that's true. And then the last one is AED is equals to x. Great. So now we are being told that determine giving reasons the value of x, right? Determine giving with reasons the value of x. So what we want to try and have here is sort of to try and have an equation where we can solve for x. And in order for us to have that equation, we need to have two things that are equal to each other, and they both have a value of x, right? In that way, x will be able to cancel each other, and then we'll be able to solve, right? So you must take that into your mind, right? So something needs to be equal to something, right? And then both of those things need to have a value of x, right? Already our angles are given in terms of x, so we should be able to do that, right? So let's see how we can approach that, right? So let's see how we can approach that. We must always use what we have, right? So what comes into my mind is what the first thing that I'm going to look at is this triangle, right? I'm going to look at triangle AED, right? I'm going to look at triangle AED. So what I know is I have this angle and then I also have this angle, right? What do I know about exterior angles of a triangle, right? So this angle. What do we know about exterior angles of a triangle, right? An exterior angle of a triangle will be equals to the sum of the two opposite angles in a triangle. So this angle will be equals to the sum of the two opposite angles in a triangle, right? So now let's write that down, right? Great. So we are dealing with 8.2, right? So we are looking in, so we don't have to write that, but we can in triangle, let's say A, E, D, right? So D1 is going to be equals to your angle E plus your angle A, right? And the reason is your exterior angles of triangle, right? So D1 is going to be, what is E? E is equals to X. What is A? A is equals to 3X. So therefore, your angle D1 is going to be equals to 4X, right? Great. So if we know that angle D1 is equals to X, we can simply also find this one, D2. So D2 will form this, right? So we know that angle D, the entire of angle D is going to be equals to 180. Why? Because it's an angles on a straight line, right? And then I know that angle D is made up of D1 plus D2. D1 plus a D2, which is 180 degrees. So I want D2, so D2 will be 180 minus D1. What is D1? D1, I already found D1 to be 4X, right? So now I have D1. So now I have D1, I also have D2, right? I have D1, then I also have D2. So let me see what else can I find, right? What else can I find? So always the idea is to use what we are given, right? How can we use this angle? So what comes into my mind is, in order for me to use this angle, I'm gonna have to look at this triangle, right? So it's going to be this triangle right now, right? Which is triangle BAF, right? Or ABF, however you want to call it. So we are going to say so we are going to say in triangle BAF, right? So now we are looking at triangle BAF, right? We still have the same thing. We have this angle, we also have that angle, and we also have an exterior angle, right? So that means that our angle B1 is going to be equals to your angle A plus your angle F, right? And the reason is going to be exterior angles of a triangle. Great. So that means that angle B1 is going to be A. What is A? Is 3X. What is F? Is 2X. So angle B1 is going to be equals to 5X. Great. Now we have angle A B1. So the same is true. If we have angle B1, we can find angle B2. Angle B2 is going to be 180 minus X. Why? It's because of angles on a straight line, right? So it's going to be the same thing. So we are going to say now our angle B2, right, So let's say our angle B2 is going to be equals to 180 minus 5x. Why? Because it's angles on and straight line. Right. So now we have this angle and that angle. So now we are trying to have a situation where something is going to be equals to something, right? And what comes into my mind is if this is a cyclic quadrilateral, right? So if this is a cyclic quadrilateral, this entire thing, if this is a cyclic quadrilateral, right, that what do we know about exterior angles of a cyclic quadrilateral? They are equal, right? That means that our angle D1, right, will be equals to your angle D2. Why? Because it's exterior angles of a cyclic quadrilateral, right? And remember, we do have D1. D1 is 4x, right? We have D1, which is 4x, and we also have B2, right? So B2 is this one, 180 minus x. So yeah, let's just do this, and we do this, right? So that's going to be our next step, right? This angle D1 is going to be equals to D2, y it's exterior angles of a cyclic quadrilateral, right? So now we come here, we say angle, in fact we can just copy this entire thing so that it becomes easy to maneuver. Cool. Oh no, we are not supposed to cut. Let's just copy and paste here. Great. Great. So remember what we said. We are looking at this cyclic quad and we are saying this is equals to this, right? This is equals to that. Great. So now continuing this, we are going to say angle D1 is going to be equals to your angle B2. Why? Because it's exterior angles of your cyclic quad. Great. So what is D1? So what is D1? We know that D1 is equals to 4x, right? We know that D1 is equals to 4x, right? And what is D? What is B2? B2 is equals to 180 minus 5x. B2 is equals to 180 minus 5x, right? So now what we have is we can just substitute. So we are going to say 4x is equals to 180 minus 5x, right? Now we transpose x. So this is going to be 4x plus 5x, right? Is equals to 180 degrees. Great. So now you are going to have your 9x is equals to 180 degrees divided by 9 divided by 9. 9 and 9 will cancel. So now you are going to have x is equals to, so 180 divided by 9 should give you 20 degrees. Perfect. Right. So now we have solved for the value of x, right? So our value of x is going to be equals to 20 degrees, right? So it was fairly easy. It was not a problem. There is another approach that you could try. which is focusing on this side of exterior angles, right? So that means that you can use the similar approach as that one that we used, but now you are going to say, let's see, yeah, now you are going to say your angle C1, right? Not really a similar approach, but you can say angle C1 is equals to this, right? And then it's going to be equals to 3C, and then you also do with this one, right? So I'm going to challenge you to do it with the other approach, right? But this is the first approach. It's not really complex. You are gonna say the second approach, you're just gonna say C1 is equals to 3x, and then you also find B2, right? B2 was gonna be very easy because it was gonna be let's see, B2 was gonna be, we have to find B2. So B2 was gonna follow the same procedure, which is exterior angles of a triangle. So it was gonna be the exterior angles of this one. So it was gonna be this plus that, right? So it was gonna be that plus that, which was gonna give you 4x. And then from there, C1 was gonna be equals to C2. Right, this angle was gonna be equals to this because of vertical opposite angles, right? But yeah, you can try the other approach, but I just find this one very easy. It was 6 marks, fairly simple 6 marks. Right, perfect. Now let's look at another question.